If you want to start preparing for any exam which has calculus, coordinate geometry, algebra, then what is the most convenient order of topics? The best way to start studying maths is coordinate geometry because it gives you an introduction to all the other topics as well. In coordinate geometry, you start with straight lines and then go towards circle, parabola, ellipse, hyperbola, etc. And then when you complete the coordinate geometry, you can then move towards calculus. In calculus, you start with functions, differential calculus, then integral calculus, then after that go towards algebra. In algebra, you can start in any order which appeals to you because algebra is like collection of somewhat independent topics. You can start with quadratic equations, polynomials, number theory, probability, permutation combination, and there are other subtopics also which I have not gone through in this video. Now, when you complete the topics in this order, at some point of your completion, of maybe when you are going through algebra or calculus, you might feel that let me cover all the topics parallelly. And when you reach that stage, you should not hold yourself back. You should then try to go through topics and subtopics in a parallel way. So you might one day be reading calculus or maybe integral calculus, and then also you might be reading something on probability or maybe something on circles. The next day you might fully devote yourself differential calculus, how to differentiate, and next day you could be fully into how to solve a linear equation using determinants. As you grow in your mathematics journey, you will realize your own path, and this path will be unique to you. And in essence, then you will find your favorite part of maths as well. And this requires a bit of practice. And when I say bit of practice, a lot of practice. When I was trying to build my mathematics in a serious way, or mathematical skills in a serious way, so the first stage was the easy stage. You look at a problem, you have a solution. I mean, it's almost instantaneous. You look at a problem, give it a minute or two, and the solution will appear on its own. When I say on its own, I will write the solution or the answer to the problem. And as I write, the solution will develop on its own as well. The second and third stage is you have a problem. You try to understand the problem first, and then you try to understand what can be done to solve this problem, and then you try all sorts of permutations and combinations of the theories you have read so far, and then you try to apply from all the aspects of those theories into your problem. So it's like you are spending almost 15 minutes at least to a problem in the second to third stage. You will also encounter few difficult problems which will consume 1 to 2 hours. And when I say it will consume 1 to 2 hours, you are thinking of the problem for 1 to 2 hours and thinking of trying to get to a solution. And at this stage, if you persevere and don't look for the answer or solution on internet or any other resource, you will grow by leaps and bounds. This I'm telling you from my practice. You have to think of the problem and think of possible approaches to the problem. Sometimes you might not get to the answer of it, and let's say there are 5 6 problems in your mind for which you have no solution approaches as well. Essentially, what I'm trying to say is you must have a starting point. Let's say you don't have a starting point to 5 to 6 problems. At that point, you start going and seeking for help. But let's say you just have one problem in your mind which you're unable to get answer to, a solution, or the first step to. Keep at it. Keep ruminating onto it. You will gradually develop your skill set using this approach.